Hello, Benjamin Williams here. Today we're going to be troubleshooting another hot standby routing protocol, Boson NetSim lab. So let's go ahead and get into it. Today we're going to be troubleshooting, like I said, hot standby routing protocol authentication. So in this lab, you will troubleshoot a hot standby routing protocol environment. Hot standby routing protocol is a networking protocol that can be used to ensure the immediate and transparent recovery of client traffic from first hop failures and network edge devices by providing network redundancy for IP networks. Authentication protects the specified hot standby routing protocol group against hot standby routing protocol spoofing attacks, which can result in a denial of service condition. So it looks like basically we're going to be going on the distribution layer switches and making sure that we have the authentication correct on these switches. You do not want a rogue distribution switch to be added to the network, and then like from there, once it's on the network, it can start sending a whole bunch of pings, just disrupt the network in general, which can cause the denial of service attack. So you do not want a rogue device on your network. So this is the topology right here that we're going to be working with. Looks like we have some redundancy throughout. Spanning trees, of course, stopping any loops. We have our access layer down here. I've already read through all of the commands and also the descriptions of each command that we're going to be using. So we got some good ones in here. So let's go down. We can see our IP address table right here for all of our devices. And then we have our PC's IP address, subnet mask, and default gateway. And then it looks like we have the desired hot standby routing protocol configuration that they give us right here. And then we have our trouble ticket. So I'm going to keep the topology right here in the top left like I usually do. And we're going to scroll down to the instructions on the top right. So this is where we're going to keep the instructions, and we're going to be doing all of our command CLI down, commands in the CLI down here. Let me actually refresh this because it's not loading like it's supposed to. 1 second. Okay, it should work now. Okay, yep. So this is what we're going to be doing our CLI, like I said. So let's go ahead and get into it. So it says trouble ticket 1. We got to troubleshoot the hot standby routing protocol for VLAN 100. DSwitch 1 is the active hot standby routing protocol for VLAN 100 on your company's network. Another administrator recently configured new security measures to comply with your company's recently revised security policies. These changes included the addition of the password, which is this password right here, to some configuration. Testing has revealed that traffic from PC1 and PC3 to router 1 is sometimes forwarded by DSwitch 2, which should not be the case because DSwitch 1 up here says it's the active. In this task, you will troubleshoot and repair the hot standby routing protocol for VLAN 100. After you fix the configuration, you should additionally verify that DSwitch 2 correctly takes over the active role for DSwitch 1 if DSwitch 1's fast Ethernet 01 interface goes down. So, first of all, let's take care of the password problem. And as I'm looking down here in the CLI, I can see that it looks like the password was configured wrong on one of the devices, and they have different passwords. So let's see what we are working with. So let's do a show. Let's do a show standby. So right here we have, for VLAN 100, we have the group 100. We have a authentication MD5 key string of this. So this looks correct. So let's go to DSwitch 2 because that's going to be our other switch that we should be working with. So let's do a show standby here and see what we get in the output. So I see the problem right here. So this is actually wrong. It's supposed to be my 80B80, but this says my 80B0. So let's go into global configuration mode. Let's go into interface VLAN 100, and let's do a no standby 100. It should be authentication. Let's do a context sensitive help. MD5 is what we want. Key string is what we want. and we wanted to say, well, we want to remove this one that says my B0 S0, and it's getting away from me. 0N, so it's Boson L485, it looks like, and then it may be an exclamation point. Yeah, so it's exclamation point. So we're going to remove that configuration, and then we're going to do a standby 100, if I can spell right, standby 100. Let's do a authentication. We're gonna do an MD5. We're gonna do the key string, and we want to do my 80 $0 N L485 exclamation point. That should fix the problem. Yep. So right there we can see that this D-switch 2 just took over for the standby, which is what we want. And D-switch 1 should be the active now, and we should stop getting these bad authentication codes, and I see it a lot now. So let's do a show standby now on D-switch 1, and we can see that this is our active. They're both acting in the virtual IP address of 10.10.100.3. So that's good. Let me do a do show standby so I can just compare the configs, make sure everything is matching up. Yep, so the priority over here is 110, D-switch 1 is 120. This has interface tracking, which is supposed to decrement the fast Ethernet 01 interface. You know, it's supposed to decrement it to -20 if this interface goes down, so it's interface tracking on this. So let's move on to testing has revealed that PC1 and PC3 to router 1 is sometimes forwarded by D-switch 2. This tells you a troubleshoot and repair the hot standby routing protocol configuration for VLAN 100. After you fix the configuration, you should additionally verify that D-switch 2 correctly takes over. So first, let's make sure that PC1 and PC3 can reach, it says, let me do a trace route. Let me do a trace RT to, it says forwarded by D. So let's do it to R1. What is R1's IP address? So let's ping the fast Ethernet 00 interface on R1. So let's trace route the 192.168.51.49. So it looks like traffic is being forwarded by 10.10.100.1. And if we look, 10.10.100, yep, so that's going through D-switch 1, which is what we want because that's the active router. And let's go to, it said PC3 as well. So let's do a trace RT. Same thing here, just to make sure the 192.168.51.49. Yep, so it's being forwarded by D-switch 1 as well, which is what we want because that's the active hot standby routing protocol on our company's network. So let's go back down to our questions. It says, after you fix the configurations, you should additionally verify that D-switch 2 correctly takes over the active router role from D-switch 1 if D-switch 1's fast Ethernet is... Okay, so now let's go into global configuration mode, and let's go to interface fast Ethernet 01, and let's shut it down and see what happens. So it went to down, and as we can see now, D-switch 1 has now went into the standby mode, and D-switch 1 should have took over, which is what we wanted to confirm. So it does. So let's do a do show standby on D-switch 2 to make sure it's active now. Yep, it is. And let's do a do show standby on D-switch 1. It should be our standby now, and that's perfect. So we got that. So let's move on to ticket 2. Configure hot standby routing protocol to load balance VLAN 100 and VLAN 200 information, I guess. So your company has consolidated a small software development staff into its corporate headquarters. The software development workstations are confined to VLAN 200 and currently use dswitch 1 as the default gateway. In this task, you will configure hot standby routing protocol for VLAN 200 so that VLAN 200 clients use dswitch 2 as their default gateway and use dswitch 1 only if the connection between dswitch 2 and router 1 goes down. The hot standby routing protocol active router for VLAN 100 clients should not be modified. So let's go on to our D switches and let's just do a show. Let's do a do show VLAN brief just to make sure we have the VLAN 200, which we do. Okay. And let's do the same thing here. So let's do a do show VLAN brief because I'm not sure if VTP is, yeah. So I guess it's populating through the network through VTP. I wasn't sure if VTP was enabled or not. So VLAN 200 is configured. So let's do a, well, we know that we don't have a hot standby routing protocol for VLAN 100 because on our do show standby, it's nothing showing up but for VLAN 100. So let's go into, let's exit and let's go into interface VLAN 200 and let's do a standby 200. And what is going to be our IP address information for this? So this is on dswitch 1. So for standby, hot standby routing protocol group 200 is supposed to be a priority of 110. Okay, make sure that's correct. Standby 200. We want preemption enabled, and we want to use a IP address. It looks like of, let's do it. Standby 200 IP 10.10.200. Move my mouse out the way. .3. And I'm going to wait to do the authentication because I want to just get the basics out the way on dswitch 2 so I don't get all of those CLI commands saying bad authentication. We're just going to do that all at once. So let's exit here. Let's go into interface VLAN 200 and do the same commands that we just did on dswitch 1. So standby 200. Our priority is going to be different on this switch. It's going to be 120. Let's do a standby 200. Preemption is going to be enabled. Move my mouse again. Perfect. And then standby 200. I'm going to give an IP address of 10.10.200.3. And let's do the authentication now. 200 authentication. It should be MD5 key string. And it should be my 80 $0NL485 exclamation point. And let's go over to dswitch 2 and get this ready to go. Standby 200 authentication MD5 key string, and it should be my 80 $0NL485 exclamation point. Enter. So let's now do a do show standby, and we should be able to see our VLAN 200 group 200 information, which we do. And dswitch 2 is the active, which it should be, because it has the high priority, which is what we want. dswitch 1 should be the standby. So let's do show standby here. Okay, that is good right there. And let's see, we're supposed to do interface tracking. I remember it said that. So let's go over to dswitch 2. And it looks like we need to do interface tracking. So let's do a standby 200. Let's track the fast Ethernet. Looks like 01 interface. And we want to decrement it by 20 if it goes down. So let's simulate a we can simulate a link outage. Let's go into interface fast Ethernet 01. Let's shut it down. Let's see what happens. Hopefully our hot standby routing protocol priority changes, and it does. Goes into the standby mode for group 200, which is what we want to see. So that's perfect. So we can do a no shut to bring this link back up. Bring this link back up. Sorry about that. A pop-up just came up on my phone. But we just had to pause for that. So let's make sure that everything is as we expected now. I think everything is good. Let me just go to the A switch to make sure that, let me do a show run right quick. Just want to make sure that the fast Ethernet 011 and 012 are actually access layer switches, access in the access mode, and they are. Okay, perfect. And let me make sure that PC3 has the right hot standby routing protocol default gateway. So it has a default gateway of 10.10.100.3, and I think that's not correct. It should be, let me scroll down here for PC3. It should have a default gateway of, okay, yep, 10.10.100.3, so that's right. Okay, that's right. I think it's PC2 I'm supposed to be looking at. Let me do an IP config. So 10.10.200.2, so that's not correct. So let's do a IP config / default gateway 10.10.200.3. That should be right now. And let's go to PC4 and do the same thing just to make sure that that is correct. So IP config. So yep, we need to change this one as well. So IP config / default gateway 10.10.200.3. That should work. So I think we've answered everything that it wants. I don't think I'm missing anything. I hope I'm not. Let's do a ping to our default gateway just to make sure. We should be able to reach it. It's perfect. Same thing for PC2. Let's do a ping 10.10.200.2. No, 200.3. It's perfect. All right, I think we're good. Let's submit this and hopefully we got everything right. So it looks like we have an error here, and it looks like it has something to do with spanning tree. So it looks like it wanted me on D-switch 2 to adjust the spanning tree priority to be 4096. So I guess it wants to be the root bridge, which that sounds about right. It needs to be the root bridge because it's acting as the hot standby routing protocol active router. So of course you want it to be the root bridge. So that makes sense. Let's go to D-switch 2. And let's go into, I think you can go into interface VLAN 200, I believe. Interface 200, and let's go into, interface VLAN 200, and let's go spanning tree. We had to do some context sensitive help here. Let's do VLAN 200. And we need to change the cost. Looks like we need to change the cost. No, not the cost. We need to change the port priority. Port priority to 4096. Is that correct? No, that's not right. Okay, I'm doing something wrong. So I need to think about this. Let's think about this. So let's hit exit. Let's go into spanning tree, VLAN. Let's do 200 priority. Yep, 4096. That should be correct. Let's try that. Yep, that's perfect. So we ended up figuring this one out. Thank you for watching. See you in the next one.